a scientist.
Suffice it that the blood of 1,000 men and women was spilled within these walls. Limbs twisted and broken, eyes gouged from bloody sockets, flesh burned black.
Please. You'll wait for dead. In death, there are no accidents, no coincidences, no mishaps, and no escapes. What you have to realize is that we're all just a mouse that a cat has by the tail.
The number you have reached, 911, has been changed to a non-published number.
Warning, the following show contains conservative posturing, radical Christian ideas, and may offend pagans, Wiccans, Islamic fundamentalists, and other unenlightened individuals. Callers and guests may be subjected to brash and offensive comments by the hosts and any other type of bullying tactics available. But that's okay. We know why you're here.
This concludes this test of the emergency broadcast system.
Tonight is Monday, March 24th, 2008.
What's up, guys?
Hey there. We just wanted you to listen to the rockin' intro. We don't normally just let you guys listen to it.
That's right.
Start yapping. This is Trent Lackey.
This is Jay Scott.
Willkommen aus.
And welcome to World of the Unexplained. I don't know what that was. Trying to do that in, oh my God.
German.
Yeah.
Well, like, Willkommen aus World of the Unexplained. I don't know how to say it in German. Ich spreche ein kleiner Deutsche.
Okay.
Anyway.
Wow. Okay.
Happy Easter.
Yeah, happy Easter
to everybody.
Yeah.
You know, I had read in an email, and some people may have had it, that this is the earliest Easter that any of us have seen, unless you're about 95 years old, when they saw it that time.
And you know it's not going to be this early again for another like 200 plus years.
And actually, 125, and then there's an earlier time, and that's the 200 plus years. When it's going to be earlier. But this is apparently how it works. The Easter is the first Sunday after the first full moon, after the vernal equinox.
That sounds all too technical for me, man, but okay.
The equinox?
Yeah.
Is it equinoxes? Well, you know what? That's pretty.
I don't know.
It's equinoxes and solstices.
That sounds good.
Because it's the summer solstice, man.
Yeah, that's right. Inside joke, guys.
That's a long
way
story.
Back.
We got 5 more hours.
That goes back to like 97 or something.
It does,
man.
when
Wow.
our failed
11 years ago.
Our failed comedy skit show.
Yeah, we should have put that together. You know, with the technology that we have today, we could have actually launched that on the internet, kind of like the Tiki Bar TV, and that would have been really funny.
We can still do it.
We could, but now we're like older and fat.
Well, I mean, that might be even funnier.
It could be.
You know, seriously.
Yeah.
You know, our minds are still sharp, but it's pretty appropriate we're talking about.
Our minds are sharp and our bodies are flabby. We are ready to achieve.
Our minds are quick. Now that's not too shabby. Anyway, that's part of my hip-hop song.
Well, tonight we've got a special guest.
Speaking of solstices and equinoxes and other
they can actually tell us what they are, probably.
Yeah, we can solve this mystery right away.
Tom Van Flandern. Yeah.
If you guys don't know anything about him, I mean, he's just, way out there.
He's an astronomer.
He is, and he has so many different theories. We're talking about black holes, the only 5 dimensions, gravity.
5 dimensions,
yeah.
Yeah.
5 dimensions exist. There's no Big Bang Theory. The face on Mars is actually artificial.
Artificial?
Oh my gosh, I mean, the list goes on and on and on.
So what do you mean the face on Mars is artificial?
Well, I mean, we can talk to him about it.
We will. Well,
So
Mr. Van Flandern, I hope I'm pronouncing that right, received his PhD in astronomy, specializing in celestial mechanics. That's the theory of orbits, for those of you like me that don't know, from Yale in 1969. So he's an Ivy Leaguer. Spent 21 years at the U.S. Naval Observatory in D.C., where he became the chief of the celestial mechanics branch of the Nautical Almanac Office. And during the past decade, he's been a research associate at the University of Maryland Physics Department in College Park, Maryland, and a consultant to the Army Research Laboratory in Maryland, working on improving the accuracy of Global Positioning System, GPS. I know GPS. I didn't know what it stood for. Anyway, so he's been doing a lot of stuff here. And we're going to talk about Big Bang Theory,
black holes.
I mean, comets, asteroids, all kinds of crazy stuff.
We'll try to fit as much stuff as we can in the short amount of time. Honestly, 2 hours is definitely not enough for this guest, and it's a pleasure to have him on
World of the Unexplained. Dr. Van Flandern, how are you?
Oh, just fine, thanks. Very kind of you to the introduction.
Am I pronouncing your name correctly?
Yes, Van Flandern is correct.
Okay, I just wanted to make sure. So tell us.
Yeah, go ahead, Scott.
Oh, go ahead, Trent.
Okay. Where are the solstices and where are the equinoxes? How does that set up?
We were just having a discussion about this beforehand.
Yeah, we're a little confused. We're not very bright.
Okay, well...
we were talking about Easter, and Easter was being after the full moon, something...
yeah, it's the first Sunday after the first full moon after the vernal equinox or the solstice. I can't remember if it's a solstice.
Yes, that's right.
Okay.
As we orbit the sun, if we look at the background stars that are fixed, it looks to us as though the sun is moving through the stars around us. And so the path of the sun through the sky is called the ecliptic, and the place where the ecliptic path crosses the projection of the Earth's equator on the sky is called an equinox. So the sun traces a path once a year through the stars, and it's going through, as it does that, it's going through the various constellations of the zodiac: Aries, Taurus, Gemini, Cancer, Leo, Virgo. That's where all those astrological signs come from. Well, on March 21st, when the sun is crossing the equator on the way up, it is passing from Pisces into Aries, and that's the vernal or spring equinox. And 6 months later, when it's crossing the equator on the way down, you have the autumnal equinox, and the sun is passing from Virgo into Libra.
Oh, fascinating. And then, of course, the other two, the summer solstice and the...
midway in between, you have when the sun reaches its maximum point above the equator, you have the summer solstice, and at that time the sun is passing from Gemini into Cancer, and then 6 months later you have the winter solstice, when the sun is as far south as it can get, and the sun is passing from, that would be Scorpius into Sagittarius, or is it Sagittarius into Copernicus? Let's see, Libra, Scorpius, Sagittarius, Capricornus. From Sagittarius into Capricornus.
Okay.
Well, I
solved that mystery. Thank you. Go ahead, Scott.
I took a very small introductory course when I was in college in astronomy, and I tell you what, the math for me was just so horrendous that I decided not to continue my studies with astronomy. But it's some really interesting stuff, really. And when you look out there and you see all this, and you've been doing this for eons, it seems. Graduating from Yale in '69, 21 years at the Naval Observatory. What I know in those 21 years of looking in the sky, and probably longer than that, because I'm assuming this is something you've done all your life, even as a child. But looking into the sky for that many years, have you ever seen anything that you would consider anomalous?
Well, there are so many marvelous things in the sky to see, and I've been interested in astronomy since childhood, and my fascination was always in predicting things in the sky that would happen. So very early on, I got interested in eclipses of the sun and eclipses of the moon, and I learned how to predict those things. And then I got interested in all kinds of other things that were also predictable, such as when the moon would pass in front of a bright star, or predicting phases of the moon, how to calculate times of sunrise and sunset, and all that kind of regular stuff. And then I got into the kind of interesting esoteric stuff, how to calculate the orbits of comets and predict when comets would return, and asteroids. And then I got into some of the really neat stuff, which is things that had never been done before, such as predicting meteor storms. There are meteor showers that show up every year, but a meteor storm is by definition a meteor rate of over 1,000 an hour.
Wow.
And they're pretty rare, but there have been a few in the last 10 years, and until 1999, when we were one of a dozen groups that tried to predict them, because they knew that the comet that produces the Leonid storms was coming by again. Our group was the most successful at making those predictions, and we went to Cyprus and saw the storm of 1999, and then went to Guam and saw the storm of 2001. It's pretty spectacular stuff, and really great fun for an astronomer to be on the leading edge of predicting something that no one had ever known how to predict before.
In all those years of looking, did you ever see anything that you would consider to be a UFO?
No, I have to confess that I haven't ever seen anything. I've seen things that looked sort of like UFOs, but there have only been two instances when UFO-like things kind of came into my area of investigation, and generally speaking, I'm only looking for stuff that's in space or out in the solar system or the universe at large. I'm not looking for things that are down here on the surface.
Okay.
But there was a report of a UFO over Mexico City in 1991 at the time of the solar eclipse down there, and I was down there at that time, and I saw the object they were pointing to, and sadly it was the prototypical case of Venus making its appearance during the eclipse, as it often does.
I got you.
And it was hanging there like a brilliant gem over Mexico City all through that eclipse. And lots of people got video of it, and you could see plainly what it was, at least with astronomers' eyes, but it was widely reported as a UFO. And there was a more interesting case that I did some investigative work on, where a Russian spacecraft to Mars reported a photograph of a rectangular object outside the spacecraft in orbit around Mars. Have you ever heard of that one?
It sounds vaguely familiar.
It was a photograph taken by the Russian spacecraft to Mars that was called Phobos 2, and Phobos is the name of the larger inner moon of Mars. And the spacecraft had rendezvoused with the moon, although it didn't land. It just tracked it along its orbit. And supposedly, according to the legend, the last photograph it took was of a cylindrical object, and that photograph was brought to the U.S. and shown around in UFO circles, and then the spacecraft failed catastrophically. Well, that isn't exactly the reality once we did the investigation. First, all the photographs that the spacecraft took were in the National Data Center archives because all the countries that have space programs share their data with one another, and it's in the public domain. And the photograph that was in question was taken about a week or two before the spacecraft failed. It took lots of others in the meantime. And whoever processed the photograph was perpetrating a fraud, because what they did was some of the photographs have a little calibration marker, which is rectangular in shape, but it's put in the field of view to give a scale to the image.
That makes sense. So
you can tell when you're photographing, for example, the surface of Mars or Phobos, how big things are. And they deliberately processed the image so that it was overexposed, so that everything in the image was either all white or all black, no grayscale at all. And then the calibration marker looked like a rectangle that was attached to the edge, so they put lots of black area around it, so it looked like the rectangle was floating in space, and it was a clear clear attempt to deceive the public and commit a fraud.
That's awful.
And that turned out to be nothing of interest to the UFO community. But I always keep my eyes open. I do a lot of viewing of the skies, and naturally I'm interested in the subject of UFOs, but have not personally seen one.
Well, maybe so, but we're about to take a break in about 5 minutes, but we might as well get started on this plethora of information that we could talk about with you. And since we're speaking about Mars, the one thing that I remembered looking at on your list and on your website was the famous face of Mars, and it says that after passing 8 different tests, you've proven that the face is actually artificial and not a natural formation. You want to talk about that? I mean, we'll talk about more after the break, but sort of get started on it.
Yeah, I'm sorry to say the connection is a bit weak, so I missed what you say when you trail off a bit there.
He was talking about the face of Mars itself and how you've learned that it's an artificial formation, and we wanted to discuss a little bit of that before the break, and then discuss it more after the break.
Yes, well, you got the bottom line right, but the story of how we get there is a long and involved and interesting one, especially since there are surprising interests, shall we say, in the outcome that go beyond just the pure scientific question of is it natural or artificial.
Okay. Well, how did you first discover that it was artificial?
The story goes back to 1976 when the U.S. sent, on its bicentennial, sent 2 spacecraft to Mars with landers, and the orbiter took lots of photographs of the surface of Mars in what we would consider low resolution today. But one of them turned up this anomalous object that looked like a face. And it caught a lot of people's eyes, and most people dismissed it as, well, naturally you see faces in clouds and faces in landscapes, so that's probably what this is too. But it was curious how irregular it was, and so a few scientists took it seriously and followed up, and they developed 8 different tests that would sort out artificial from natural, and then proceeded to perform the experiments to complete those tests. And when I came along in 1996, when I got active in this research, at that point 5 of the tests were coming out in favor of artificiality, 3 of them in favor of a natural origin, and 2 of those tests I'd proposed myself. I said that the face can't be seen from the ground on Mars, so if anybody built it to look like a face, it was meant to be viewed from above.
Okay.
And so naturally you would do 2 things. One is you'd build it on the equator so it can be seen by anybody approaching from a spacecraft or orbiting Mars. And secondly, you would build it upright and not tipped over at an angle. And neither of those was true. But at the end of 1996, we discovered that Mars has not always had its present orientation. It suffered a major cataclysm a little over 3 million years ago, 3.2 million years ago. And at that time, the pole of Mars, the geographic pole, was tilted extensively relative to where it is now. And someone noticed that the old pole of Mars was in quite a different place than the present one, and they wrote and asked me where was the face on Mars relative to the old pole. And when I looked it up,
the equator,
it turned out to be not 90 degrees away, pretty much dead on, meaning that it was on the equator, and more importantly, it was upright with respect to the old pole.
Oh, wow.
Wow.
And the odds against that being chance were 1,000 to 1. We still didn't consider that proof, but that's what set me into the active research on that project that got me into the Society for Planetary SETI Research, a group of independent scientists investigating any claims of planetary artifacts. And there's more to the story, but it would then led to further tests that involved the new spacecraft that went to Mars in 1997, the Mars Global Surveyor, and the results that came back from that raised the level of certainty with which we can distinguish an artifact from a natural thing to pretty much remove all doubt on that.
That's
you said you had to take a break.
Yeah,
we're getting at the top of that right now. If you'll hang tight with us, you're listening to World of.
Go ahead.
You're listening to World of the Unexplained. Tonight's guest, Tom Van Flandern. If you want to give us a call, we'll open up the phone line soon, 877-722-7382. That number toll free in the U.S. and Canada, 1-877-SCARE-U2. We'll be back with Dr. Van Flandern after this.
And we're back, World of the Unexplained. Tonight we have Tom Van Flandern. The lines are open, 1-877-722-7382 or 1-877-SCARE-U2. Locally, 336-996-1596. Give us a call. We're talking about Mars. Specifically, we're talking about the face of Mars. And you were saying before the break that Mars had suffered some kind of cosmic catastrophe or what have you that actually shifted the planet. And before that catastrophe, the face of Mars would have been put dead on the equator and upright. But now it's shifted to a different position. Now, briefly, what were the tests that you guys had come up with to determine that it was of artificial and not natural origins?
Well, the original 8 tests were things like using military software that was designed to search for artifacts in camouflage and applying it to Mars. And the software caught the face on Mars as a suspect artifact. And the original Viking photos only showed the west side of the face, and so the east side was in shadow. So what would computer enhancements of the shadowed side show? And the answer was that it turned out to be a fairly a good approximation of a symmetric side of the face, and that sort of thing. The 2 tests I mentioned that I'd proposed were it should be on or near the equator and upright, and it turned out that was true if it was built before the catastrophe at 3.2 million years ago. But all that was just kind of a prelude to what happened next, because the SPSR group, the Society for Planetary Study Research, was 30 independent scientists studying this, and they thought that there was enough evidence that NASA ought to give some priority to taking a new image. So they approached NASA in the fall of 1997, and NASA agreed to go to the Jet Propulsion Laboratory, which was its independent contractor operating the spacecraft, and request that they give priority to taking a new image of the face on Mars region of that region of Mars is called Cydonia, and the face is one of several mesas or special geological features in that area called Cydonia. NASA went to JPL and requested the images, and at first JPL refused to take them. There was some negotiating going on and back and forth, and finally NASA agreed to pay JPL an extra few $100,000 and give them more personnel for the project just to take 3 photographs in the Cydonia region. JPL, being very reluctant to do this, said to the other scientists that they considered this a slap at the integrity of the scientists and their independence and a waste of public funds. But they agreed to do it, and they took the first high-resolution image of the face mesa under very unfavorable viewing conditions, with the spacecraft way about 500 kilometers off to one side, and so you couldn't even see over the nose ridge on the mesa. and they took it with the sun at a low angle toward the horizon under the chin, which kind of distorts faces and makes shadows weird anyway. And they took it on a day when the atmospheric transparency was very low. But all those problems aside, when they took the image, the scientists who looked at the image were completely floored and amazed, because what had happened before the image was available to anyone on Earth is that the group of scientists had said amongst themselves and publicly that here is the crucial test. In the Viking images, all we can see is a fairly regular-looking mesa, fairly symmetric mesa, with the impression of an eye, the impression of a nose, and the impression of a mouth that could easily be tricks of light and shadow. But if and only if this is an artifact that was intended to look like what it appeared like, a humanoid face, if and only if it was artificial, then the eye socket should be symmetric on the other side and should have an iris in it. It should have an eyebrow over it. The nose should be tapered. It should have two nostrils at the end. The mouth should have parted lips, or should be obviously composed of lips. The chin should be rounded, and so on. All these features that are true of faces on Earth ought to be true there too, if it was someone's deliberate attempt to portray a face. And on the other side of the coin, the high-resolution image should look like craters, valleys, ravines, sand, mesas, natural geological features of all sorts, but the impression of a face ought to go away in high resolution. What we actually saw in those images, and by the way, because of the discipline of scientific method, it's too subjective to just say there ought to be something that looks like an eyebrow or an iris. The scientists wrote down a table in advance of how big and how small, what size, what place, what range of places, what range of sizes, what range of locations, what range of shapes, what range of orientation would qualify. And anything outside the ranges written down in advance would be considered just human minds trying to find order in randomness. And we tend to find faces even in randomness when it really is random. Okay. So to avoid that, all these features were specified in advance as to what range they could satisfy, and even that wasn't sufficient. It had to be the case that a feature like, say, an eyebrow or an iris or a nostril was not only with the right size, shape, location, and orientation, but nowhere else on the mesa, because human brains would then pick and choose things that look like eyebrows or irises or nostrils just because of our predilection to see faces. So they can't be anywhere else, just at the exact spot where they should be if this thing was going to be declared artificial. And the bottom line is that when that high-resolution picture came back, as bad as the observing conditions were, it showed an eyebrow over the west eye socket, the one that was visible, an iris in the eye socket, two nostrils at the end of a tapered nose, the mouth consisted of parted lips, there was a chin feature, everything that had been predicted in advance, well within the range of specified for size, shape, location, and orientation, and nothing else that would qualify as any of those features anywhere else on the mesa, and the mesa itself looked more symmetric than ever before. The combined odds against those things happening by chance, the combined odds against something looking like a face in the original Viking images were pretty long. We don't see things that look face-like, that much face-like in nature very often. But the odds in advance don't matter when you come on something like the Viking spacecraft did. All it does is allow you to set up tests for later confirmation. Basically, your probabilities are only significant for the next example you find, not the first one. So only the predictions of things not already known, such as the eyebrows, iris, nostrils, and lips, qualified under scientific method, and those things predicted in advance had combined odds of thousands of billions to 1 against all being there by chance. So that the group concluded ruled out the possibility that the face on Mars was any kind of accident of nature at those very long odds.
I would imagine so. That's that's quite something. I guess I have another question concerning Mars, but one more speculative question. Okay, now that you've created the possibility, or not possibility, set it as an artificial structure, how do you speculate it was constructed? Is it simply a natural mesa that some group of sentient beings had carved out, or is it built? Like, for example, I don't know, the Sphinx, for example. Have you thought about how the actual face was constructed?
Right. Well, of course, we didn't have any definite knowledge about that, but there is over in the lower right corner of the face, the part that wasn't visible in the early photographs but became clearer in later photographs. There is an impact crater, or some kind of a crater. It actually doesn't look like an impact crater, but it's a circular feature, and it has damaged the mesa in that corner. And one of the scientists commented, it looks collapsed. It looks as though maybe it was all symmetric and regular at one time, but whatever made the circular impression collapsed to that corner of the mesa. So if you buy that argument, then that would suggest that there's a lot of hollowness underneath for it to be able to collapse.
Okay. Very interesting. And actually, moving on to that, also on the list concerning Mars, you talk about two things that, for example, that living bacteria have been discovered on Mars, and that there is a network of largely underground glassy tubes. I don't know which one you want to tackle next, but one of those.
Well, both are interesting stories. The very brief story on both is that the Viking landers in 1976 both took scoops of soil and did all kinds of analyses on them to test for life. And they had 3 life detection experiments plus an organic an experiment that tested for organic molecules, which is a prerequisite to life. Going into the mission, the scientists assumed that the 3 life detection experiments would be negative and that the organic molecules test would be positive, because there must be organic molecules on Mars because they come in from comets all the time from collisions.
Okay.
But the reality was, when the tests came back, the 3 life detection experiments all got positive signals, and the organic molecules test came back negative. And so the conclusion at the time was, well, it can't be life as we know it without organics. But the principal investigator in one of those experiments continued to work on the problem and found no other way to get that signal except life. And he found the problem with the organic molecule instrument was that it wasn't sensitive enough. It also registered negative on a sample from Antarctica with a known virus in it on Earth. And so it showed that the experiment was just not sensitive enough to detect organisms in the soil. So he published several papers concluding that the soil of Mars had living organisms, not microfossils or long dead ones, but living ones at the time of the landing in '76. The glassy tube story Just a footnote on that. Since then, the Mars Express spacecraft has added punctuation to that finding because it has found methane in certain regions of Mars that are associated with things that appear to change with the seasons. And the only natural sources of methane are volcanism or biology, and there is no active volcanism anywhere on Mars that we can see, but there are some hints of biological activity, and the methane is closely associated with those areas. So that and some formaldehyde and a few other indicators that are usually unique to life have come out positive also in very recent results from orbiters.
Wow. That's
then there's the glassy tubes controversy. In many of the images that are returned from Mars, in thousands of them, in fact, we see these objects that have been called by the generic name glassy tubes. Simply, we don't know what they are, but that's kind of what the impression they give the eye is. We know that they are large, long, roundish features that are encircled by bands. The diameter is typically 50 to 100 meters, maybe a few hundred feet. And the white bands completely encircle them. The rest of the tube between the bands is translucent. That is, you can see through it. You can see the bands going all the way around to the bottom side. When the sunlight reflects off the tubes, you get a specular reflection, again suggesting it's not a natural terrain, it's some sort of a flat, shiny, reflective surface. The tubes have junctions in certain places. They don't, the explanations of lava tubes or sand dunes were put forth early on. They're proof certain that they aren't those, though we don't know for sure what they are. But they run subsurface in most places, and only where the surface is broken or exposed do we see them. They run close to one another and have junctions, and there are places where there are even what we might call terminals, if these were familiar things on Earth, places where many tubes from different directions all congregate, run parallel to each other for a while, and then take off again in different directions. And as I say, they don't run randomly about the surface. They go from one interesting place on the surface to other interesting places. Again, if all this were taking place on Earth, we wouldn't have much hesitation in concluding that there had been an ancient civilization that had built these things, and they were doing the kinds of things that would be natural for a civilization to do. But here we are seeing these things on Mars, and it's as shocking to the scientists as it probably is to you and your audience hearing it, because we can't prove yet that they're anything particular, but all of the evidence we can find suggests that they are of an anomalous character that is consistent with what we would call artifacts. That is, of the couple 100,000 high-resolution images returned from Mars by the Mars Global Surveyor, something out of the order of 1,000 of those images return something in them that if it had been a photograph taken on Earth, we would have not hesitated to call artificial and the product of man or large-scale biology. But since they're photographs taken of Mars, we're very hesitant to say anything about it in public.
That's really, really fascinating stuff, actually. And I guess it's close enough to our break. I don't want to cut you off in mid-sentence, but we'll talk maybe a little bit more about Mars and then some other interesting things out there beyond our little world. We'll be back with Tom Van Flandern right after this.
Back on World of the Unexplained tonight, our guest is Dr. Tom Van Flandern. He has his PhD in astronomy, and he's been doing this stuff a long, long time. So he's seen about everything there is to be seen out there as far as the human realm is concerned. I think much more so than anyone we've talked to. You can give us a call here, 877-722-7382. That's toll-free, 1-877-SCARE-YOU-2, or locally 336-996-1596. And please go by and check out Dr. Van Flandern's website. You can get that information at www.metaresearch.org. That's META research.org. And we were talking when we left at the break last time about Mars still. Trent, I know you had another question for me.
Well, I mean, basically, briefly, seeing as we've spoken about the face, other kind of interesting structures, the glassy tubes, the presence of single-celled life, as it were, cataclysms. What kind of synopsis would you put if there was life on Mars? What then happened to it? If you could just kind of briefly wrap it all up about Mars.
Well, we are a long way from having all the answers we'd like to have, and that's one of the reasons I'm in favor of manned exploration of Mars, to get more answers and find out what's really going on. But what conjectures we can make from the present time is that living bacterial organisms seem to survive even down to the present day. And by the looks of things, based on some of these other anomalies, I'd say that there are probably even large-scale biology things. There are things that look so much like shrubbery or trees on Mars that have a lot of characteristics of those, the way they change with the seasons, the coloration, branch-like structure. So biology may still be present on Mars. That's a question that we can't definitively answer for the future, because the landers we have going there these days, the landing sites are chosen for safety of landing rather than for scientific interest. But that will change in the near future. The long-term picture here, what's going on with these artifacts, is a subject of very much conjecture, and it's almost anybody's guess. But the kind of theories that are coming out of this, why does the face on Mars, and not just the famous one, but about half a dozen others, why do they look so hominid, so much like us, rather than alien or insect or any of the other kinds of faces that exist in the animal world, or in the larger world of possible extraterrestrial life? Why does it look like us? And also, why 3.2 million years ago? That's a coincidental date, because it looks as though that cataclysm that occurred to Mars at that date might have ended the builder's civilization. And just about that time, the hominid species as such was getting started here on Earth. The oldest humanoid fossil that we found is the Lucy fossil, which dates also from 3.2 million years. So it's as if one civilization was being brought forcefully to an end, and another one was just starting at around the same time. So the mind is begging to speculate that there's some kind of a connection that we have yet to discover.
And hopefully we'll get some answers on that. But from Mars, we're gonna shift on over to the Moon and talk about that.
Yeah, I was wondering. A lot of people mentioned the smokestacks, the smokestack. I don't know, plural or singular, that appears to be on the Moon in certain pictures. I think all those are related to some pictures during one of the spacecrafts orbiting the Moon, taking video. Are you familiar with this phenomenon?
I'm familiar with a feature that I heard described as spires, which might be the same thing. There was no smoke associated with them, but they were apparently anomalously tall based on the shadows they cast, Would that be the same ones, or are you talking about something different?
I don't know. It looked like from what it looks like from the video that I've seen of it on the internet, you just see the moon. You see something that looks like a puff of smoke, just like come off the surface of it, as you see like a tall shape, like you were describing earlier. It was more of like a tall, kind of small, I don't know what, rectangular shape, and then you see this puff of smoke, or what appears to be a puff of smoke.
Yeah, I have not seen the puff of smoke images, but I have seen some images that were being touted a few years back of things called spires, because they seemed anomalously tall, almost like monuments or something, very, very tall and slender and casting long shadows. And the explanation on those was that it appeared that the sun angle wasn't low enough to cast a long shadow, but later investigations with lunar orbiter and with radar showed that the terrain in that area was sloping downhill, so that even though the sun was at something, I forget the exact figure, something like 8 degrees, the slope downhill was a comparable amount, so that even a very small object would cast a very long shadow. So they weren't as tall as they appeared to be in the image, based on the shadow.
Well, right now we have a caller. I believe it's Ron from Raleigh.
Ron Hunter from Raleigh.
Hey, Ron, how you doing?
I'm doing just fine. Hey, Dr. Van Flandern, how are you tonight?
Just fine, Ron. What can we do for you?
I wanted to congratulate you. I read your book, Dark Matter, Missing Planets, and New Comets, quite some time ago, and I think it was one of the better books I've probably ever read on science in my life. Certainly the information you're going over, we should send more explorations to Mars, perhaps even a lander there. Does that sound like a good idea?
Yes, I'm very much in favor of manned exploration of Mars, because I don't think we're going to get the answers we're seeking from robots. If you can only program a robot with so many choices, and if the robot goes up to one of these interesting artifacts and sees a door or a window,
right, it could send a picture back, and that would be conclusive evidence. So you're saying before that this structure was on or near the equator of Mars, and then there was a large explosion that tilted the planet? Could you maybe elaborate on that and explain some of your other theories? Like, I think some of your theories are extremely well written and amazing, like your sphere of influence for gravity, the C graviton model. So could you sort of explain our solar system a little bit and what you think has happened in its recent past, and maybe a little bit about comets and how they break up and how moons might be captured? I found all that very fascinating. And I know this is the point about the anomalies on Mars speaks for itself, like algorithmically speaking. If there are that many points of coincidence between a simulation and a theory, then that requires further investigation to be scientific, right?
Yes, that's right. You gave me quite an assignment for the
yeah, I know,
hour.
But you got so much brilliant material that I think you really made a strong point for the face on Mars. I'd like to hear more about some of the other things in the solar system, especially about comets, and I think some deep impact research that you've done and some predictions that you made along those lines.
Okay, well, for the moment, I'll take the cataclysm on Mars, and we'll turn it back to the host to see where we want to go next.
Okay.
Yeah.
There's one of the first surprises about Mars when spacecraft first got there and started taking pictures close up was that half of Mars was pretty much as was expected, that is, saturated with craters, very much like the moon and most other planetary surfaces or moon-like surfaces in the solar system. Saturated with craters means basically you can't lay down any more big craters without destroying other craters underneath. But the other half of Mars was flat and smooth and featureless and very few craters. And so there was talk right from the outset, what on earth happened to the other hemisphere of Mars? And they thought there was some kind of a catastrophic event that destroyed all the craters, a massive ocean, a massive lava flow, something. But it was pretty close to a full hemisphere of Mars. We now, the latest evidence that I've been writing about, and you can find more about it in my book or on the website, metaresearch.org, is that it was the other way around, that the atmosphere on Mars degraded the craters just as it does on Earth through weathering and erosion, and that the smooth hemisphere is the normal one, but the cratered hemisphere is the result of an explosion event, and not an explosion that happened on Mars, but rather one of its former moons exploded. Skipping a lot of details that you'll find elsewhere that aren't relevant to the event. Apparently, one of the findings of the modern age is that planets and moons do explode, just as stars are known to do. Although we're talking about over billions of years, not anything we need to worry about with our planet.
You mean the frequency, not the time it takes to actually explode, right?
That's right. Apparently the last explosion near Mars was this one 3.2 million years ago. One of its moons, a body orbiting Mars at that time, blew up, and Mars was keeping the same face toward the moon, and the moon same face toward Mars, as often happens throughout the solar system, as is true of our moon. And so it was Mars was cratered on only one side, one hemisphere, and it was cratered very thickly on that hemisphere, and the crust on that hemisphere is built up to a thickness of 20 kilometers, tapering off toward the edges, and then you come to the flat, smooth hemisphere on the other side, which is just 1 kilometer thick.
Does this leave any evidence on Earth, Doctor?
Sorry?
Was the moon explosion powerful enough to leave any evidence on, say, our moon or anywhere on Earth?
Yes, it was. There was an increase in cratering, a mild increase in cratering on the Earth at that time, 3.2 million years ago, but more conspicuously, there was a sudden change in the content of the atmosphere and the oceans on Earth from the blast wave of this explosion coming our way. It didn't leave as much debris as it did just a lot of meteors in the atmosphere and changing the content of things. And it apparently changed the climate, because that's when the series of ice ages began, from a fairly tropical Earth all over to intermittent ice ages and warm periods. That began about 3 million years ago.
Does that imply some kind of orbital change? Or how big was this moon, in comparison to our own moon? Was it many times the mass of the Earth's moon, or would it have been something smaller? The one that exploded 3.2 million years ago was a body only a little bit smaller than Mars itself. Which is a lot bigger than our moon, right?
Yeah, Mars is perhaps 1 order of magnitude bigger than our moon, but 1 order of magnitude smaller than Earth.
Gotcha.
And one of the things we talk about in my book is that there's plenty of good evidence that Mercury is not an original planet, but an escaped moon of Venus. It's pretty similar to our moon, and our moon is moving away from the Earth and would have escaped too if it had been a little bit more massive, the way Mercury was. And we think that Mars also was originally, Mars and this other body were originally 2 moons of a planet that exploded 65 million years ago, and the damage that did on the Earth is well known: the death of the dinosaurs, a global fire, and all kinds of other cataclysms on Earth, even though we're quite far away.
The fragment that hit Earth 65 million years ago may have been a piece of a planet that had exploded somewhere in our solar system, but there was a fairly large planet, and the debris covered the whole solar system, but some of it impacted on Earth, and one of these pieces was a tremendously large piece.
Yes, well, actually there are now 16 known craters on Earth right at that same time, and still counting. The Chicxulub impact is just the largest of a large number of craters that hit around that time. And then we had the Deccan Traps, an episode of major volcanism on over near India right around the same time, where apparently an impact punctured the crust and produced a massive lava outpouring. It was not a pleasant place to be on Earth 65 million years ago, and 70% of all species perished. That's about 99.999% of all life
Wow.
Because 70% of all species perished 100%.
Wow, that's really something. Ron, thanks for the questions. They're excellent. We'll try to get it to the the other theories, but we may need a whole another hour and a half to do it.
I know.
Just
Well,
kidding.
the other ones were the purely physical theories of like the virtual photons and the C gravitons. I believe you had coined that phrase. But I thought those were just so amazing. It was a showstopper the first time I was introduced to it, and it changed my way of looking at astronomy. So thank you very much for having me on. And thank
Okay.
you.
Thanks, Ron.
All right. God bless you.
Yeah, thanks, Ron. Take care.
Wow. Very fascinating stuff. Actually, I guess we'll there's another follow-up question concerning that, trying to tie back with our moon. Basically, where you speculate that our moon originated from the Pacific basin of the Earth. Now, I've heard some kind of other kind of a theory like that that our moon is actually part of our own planet that just kind of split off. But could you explain that a little bit further?
Sure, happy to. There are three classic theories and a fourth modern theory for the origin of the moon. Basically, they're the idea that the moon came from somewhere else and was captured by Earth, or the idea that the moon formed alongside Earth around the time Earth was forming and was always in orbit, or the idea that the moon was once part of the Earth and split off. And then the new modern theory is that a large Mars-sized impactor came along, made a grazing impact on Earth, and knocked off the debris that later formed the moon. So those are the four theories. In the book, I argue that really the only one that all the evidence is consistent with is the fission theory, where the forming Earth began to condense and contract from gravity as it built up, and as it did so, it would spin faster and faster, like an ice skater pulling in her arms. You'll spin up to conserve angular momentum. Finally, the Earth spins so fast that centrifugal force is stronger than gravity, and you can't help but breaking off part of the crust and throwing it into space. And the moon was then formed in that way from material broken off a rapidly spinning Earth. And then the moon's orbit was initially very close to Earth, and it evolves gradually outward through tidal friction. The moon still raises tides on the Earth, but back at the time when it first broke off, the tides were a mile high. The moon has a significant gravity, and when it was that close, it was doing a lot of damage to her. So that's why it took life quite a while to get started, even here on Earth.
Yeah,
and
that,
I think, is the leading theory for the origin of the moon and the explanation. I think that in part because we can use the same model to explain the origin of all the planets and all the moons, not just our own.
Oh, certainly. But how do you speculate that the moon originated from the Pacific basin of the Earth? That's
yes. Well, that's an idea due to Charles Darwin, not the evolutionist. He noted that if you look at a map of the globe, the continents of North and South America neatly fit together with the continents of Europe and
Pangea,
Africa. And, of course, we know that the Atlantic has been widening, and that if you go back in time, those continents were once together. So that leaves the Pacific Ocean covering a little more than half of the planet. And interestingly, the moon's surface content is mainly basaltic rock, which is exactly what we find on the Pacific floor. So the theory says that when the moon broke off from the Earth from overspin, it came out of the Pacific basin, and that's what took the landmass out of the area that has since filled in and become the Pacific Ocean, and that subsequently the large continent that was left on the other side of the planet began breaking apart into the several continents that we have today.
That's pretty crazy. I've heard a lot of theories about the missing Pacific continent, but I haven't heard that one yet. And finally, in the last couple of minutes, and then we'll move on to something else. Apparently the moon does not show us the same face as it used to. Had a different face. Could you explain that one?
Sorry, I didn't quite catch that.
I'm sorry. In the last couple of minutes here before the next break, you speculate that the moon no longer shows us the same face that it used to. Well, what happened?
Our moon, no, there's been no change there. I think I was alluding to a moon of Mars.
Oh, okay. I'm sorry. Oh.
But our moon always keeps the same face toward Earth.
Right.
And it wasn't until the space program that we ever got to see pictures of the other side of the moon. That's not unusual. The large moons of all the planets in the solar system all keep the same face toward their parent planet.
I see. Well, okay. Yeah, I guess we'll go on to this. A little bit of time we have left. And we'll go on past the break. But one of the big things that I heard about was that you speculate there are no black holes in the universe. That seems pretty shocking, because I always assumed that somewhere out there they existed. And, of course, we'll move on beyond the break. But just get started on that. I know.
Well, I think the biggest shock, it certainly is to a lot of my professional colleagues, is that I'm in very good company in that theory.
Oh, yeah.
Because the originator of the theory that there can't be black holes was Einstein himself.
Huh.
He published a paper in 1939 showing that his theory could not possibly allow singularities, as they're called in the technical jargon. The phrase black hole hadn't been invented yet. That came along from Wheeler in the 1950s. But he was talking about the math that Wheeler used later to predict black holes. He said, no, that isn't allowed in my theory because it would require collapsed matter to exceed the speed of light, and that's just not allowed in my theory. So he said, nope, there are no black holes in my theory, but not in so many words, but by saying the technical equivalent of those words, no singularities. So the basic idea here is that there are two kinds of physicists out there today. The mathematical physicists tend to love the power of mathematics, even though many times mathematics takes us into domains that are not physically possible, such as infinities in nature. Mm-hmm. And that's the case with black holes. In order for matter to collapse all the way to a black hole, the forces would have to approach infinity as a collapse occurred and actually reach infinity when the collapse was complete. And that violates one of the principles of physics, that the finite can never become infinite. So there must, at some level, somewhere down the line, be something that stops the collapse. And then you would get what, instead of what Wheeler predicted in the 1950s, you would get what Mitchell predicted back in the late 18th century, in the late 1700s. And they're called Mitchell stars, which are highly collapsed stars, more collapsed even than white dwarfs or neutron stars, that nonetheless reach a limit, and then just because of their very strong gravity, they would redshift light. But light could still escape, though only at very long wavelengths. And they would still be reasonable objects, not objects that have infinite force at the center and are able to reverse space and time and do all kinds of fantastic things, as in the kind of physics that comes out of the pure mathematics if you ignore physics.
Oh, I see. We'll talk a little bit more about that in the last half hour here at World Explained. Tom Van Flandern on with us tonight. We'll be back in just a few minutes. 1-877-722-7382. I knew that might have happened. Or 1-877-SCARE-U2. Locally, 336-996-1596. And Tom Van Flandern's website is meta, M-E-T-A, research, as in the word, .org. Is that correct, Tom?
Yes, that's right.
Okay. Actually, let's get into this topic, this pretty heavy, weighty topic about time and space and dimensions. one of the things that you talk about is that the universe has 5 and only 5 dimensions. Now we have all heard these theories of string theories and infinite number of dimensions where somebody else is president or this, that, and the other, all these possibilities based off of a variety of things. But you say there are only 5 dimensions in the universe. Could you explain that a little bit?
Well, it comes from a different way of thinking about the universe. Of the 5 theories we have on the table right now to explain the origin and nature of the universe, including the mainstream one called the Big Bang Theory, 4 of them were derived by induction, meaning that you just kind of look around you, observe the universe, and guess how it got to be the way it is. There is another approach, though, the one that I preferred, and I've recommended this kind of deductive approach very much in my book. The idea is you start out with nothing, a universe that is completely devoid of anything, even space and time, any content, whatever, and then introduce just one element of substance, existence, and derive its properties. Well, there really aren't any properties, because with one element you can't tell if it's moving or non-moving. You can't tell how big or small it is. You can't tell anything about it. It's just there. Mm-hmm. But then you bring in a second unit of substance, and if the two ever come into contact, that would be a distinguishable event. And if they come into contact, go apart, and come back into contact, that's 2 events, but you don't have any way of telling how far apart those were. It could have been a millisecond or a million years. So you could keep building in this way, and you gradually see the concepts of time and space evolve out of the picture as you build it. And when you, to skip over a lot of steps in building the universe, when you get to the bottom line, it tells us some very interesting things that we didn't know before about the real nature of space and of time and of forces and about things that we've always had thought about and had guesses about. But when you work deductively, you can get a better sense of it. So time isn't something mystic or mysterious that can be dilated or warped. Time is simply a measure of change in the universe. And space is a measure of separation. And mass is a measure of the amount of substance in bodies. And there's a very simple and effective way of looking at things, because when we build the universe in this way, the amazing thing is we deduce properties that are very much like what we observe, only with a different twist to our understanding of what it was all about in the first place. And when we're done building, we wind up with 5 and only 5 dimensions, 3 of space, 1 of time, and 1 of mass or scale. And as long as we can explain everything in the universe, and so far we can, even in all those mysterious things in quantum physics with 5 and only 5 dimensions, it just isn't rational to introduce additional dimensions, because it's sort of like introducing miracles into physics. The reason we don't allow miracles into our physical theories is because once you invoke a miracle, that ends all hope of understanding it or explaining it or predicting it, because of what a miracle is by definition. And understanding and explaining and predicting are the goals of science. So you have to do it without miracles if you possibly can. And so far, we've been able to build and understand a universe with 5 and only 5 dimensions and with no miracles. And when I say miracles, that means that we respect the principles of physics which come from logic alone. Things like every effect has to have a preceding and proximate cause. The cause has to precede the effect logically, and something has to come into contact with the affected agent in order for the effect to be transmitted. Another principle of logic is you can't get something from nothing. So creation is the ultimate miracle, but it has its counterpart. Something can't become nothing either. So to explain that a little further, we talk about things being created, buildings, even people, all the time, or created and destroyed, but we don't really mean created from nothing. They're always created from parts, and they're destroyed back into parts. When something is destroyed, whether it's blown up or taken apart, you can account for every atom, every molecule, every bit of it. It still exists in the universe in some form or other. You can't you can't make something become nothing, and you can't make nothing become something. Principles of logic. So when we get back to these principles, which are usually ignored by the mathematicians, and when we work deductively instead of inductively, which is educated guesswork, we get a different but very comforting and very reassuring picture of the nature of all these concepts, such as space and time and mass and scale and forces. And this is the story of how we came to this idea and what the deductive picture is, how it proceeds, and what it tells us is the first 5 chapters in my book, Dark Matter, Missing Planets, and New Comets, the rest of which is all about the history of the individual planets, eclipses, the mysteries of the solar system, the Mars anomalies, and all these other interesting things.
Okay, so what amongst several of the things you were talking about, something can't come from nothing, and that basically is what you would use to strike against the concept of the Big Bang Theory, that all of a sudden there's just a pow, and then here it is. But before then there was nothing. And then
to put a fine point on it, for those who are strongly religious and feel that God does work miracles, we're not denying God or the possibility of miracles so much as we're saying physics is obliged to explain everything without miracles if it possibly can. And the good news is that so far we're not having any trouble understanding the nature of the universe without miracles, because we don't need that first miracle, that origin event, that Big Bang. There are only 2 possibilities when you speak of the origin of the universe. Either something began from nothing, which requires a miracle, so that's the forbidden answer, and the other one is the universe never had a beginning, and that's the non-miraculous one, so the one we're obliged to accept.
That's really...
On a scientific...
Huh?
On a scientific level.
Yeah, on a scientific level. That's really, really heavy. Now, when you talk about 5 dimensions, kind of briefly talk about their nature. Obviously, I'm assuming that we're in the 3rd dimension, supposedly, and then what about the other 5? What makes them different from our own dimension? If you can get into that.
Well, it's just 5 altogether. Space is 3-dimensional. The 2 for example, on Earth, you can on any flat surface you can go either east-west or north-south. Those are two dimensions, and then you've got up-down as the 3rd.
Okay.
So you can have lines, squares, and cubes for 1, 2, and 3 dimensions, respectively. So space always has 3 dimensions, and there's no present either need or value in conjecturing about a 4th dimension of space, because we don't have any phenomena that require one or even would benefit from one. And it gets us into all kinds of logical tangles when we throw in things that are unnecessary. It's sort of like throwing in miracles. So then the 4th dimension was written about and discussed by Einstein, that's time. And there are ways in which time can be treated as similar to space, and there are ways in which time is unique. For example, in time being a measure of change only goes one way. When change happens, that's forward time, and even if you undid what happened, you're still marking off more forward time, more change. So time is necessarily one directional, but that's the fourth dimension. And then the fifth dimension is mass or scale, the large and small. And when we say that the universe itself has no limits in any of these dimensions, that's what the meta-model concludes. That means that as far out as you can go in space in all directions, there are no limits. There is no beginning or end to the universe, because nothing can ever be created from nothing, and nothing can ever go back to nothing. So in the future, the universe can't end. In the past, it can't begin. It's always been pretty much the way it is today, except for the details. And then when it comes to scale, that's the interesting one. It means that all the kinds of things that we see at our scale are forms, and there are similar kinds of forms at every scale, so that if you went down inside the smallest subatomic particle inside an atom, that might be a whole world or a whole universe to some other kind of infinitesimal living conscious entity.
Whoa.
It's infinitely divisible all the way down. There's no such thing as the smallest possible particle, because that would lead to all kinds of paradoxes.
Right.
Study of Zeno's paradox.
Yeah, Zeno's paradox. I was about to point that out. You can keep, and then that paradox run, you can keep on dividing something in half, and you'll always have two halves, no matter how small it gets. And then, am I right about that?
Yes, that's right. That's
Okay.
That's Zeno's paradox, and it's a very interesting study. But when you go through all the steps, it leads us to conclude that everything has to be infinitely divisible, because the paradoxes really only stay unsolvable if you say there's a smallest particle, smallest possible particle. And likewise, on the large side, if the universe is infinite especially, you can keep building up structures forever. We keep discovering bigger and bigger structures in the universe around us. For a while, stars were the biggest thing, then galaxies, and then we had clusters of galaxies, then superclusters of galaxies, then great walls and voids, and now we're finding even structure larger than that. So there's probably no limit to it on the upside either. And on some very large scale, our whole universe may be just a raindrop on somebody's forehead.
Oh my gosh, Tom! You know, I've been sitting here. Listen, I just have to go, whoa. You know, I almost have to like sit here, and probably about 4 or 5 hours, I'm still going to be thinking about that. Just that very concept is just.
It reminds me of Men in Black.
What's that?
With the galaxy from Men in Black.
Oh yeah, that's
in
right.
The movie, it shows the Earth. All it is a marble.
Yeah. Right, like the end of Men in Black. That's right. Oh my gosh, that's some really heavy stuff. And yet at the same time, it seems to make, as you were talking about, perfectly logical sense. You know, you're not trying to, you know, it's not smoke and mirrors. You're just using common logic to deduce that. And that's really fascinating. I guess one more little question then. Is it possible for matter and mass to travel faster than light? Could it be done?
Yes, but I hope you're not short on time for that one.
Well, yeah. Okay. Maybe.
I was just curious if that was possible.
The very short story is that followers of Einstein's theory know that Einstein's theory comes in two parts, the special theory and the general theory. And the special theory has a proof that nothing can go faster than the speed of light, because if as you approach the speed of light, time slows down and would stop by the time you got there. So if time ceases, you can't possibly go faster than that.
Oh, I see.
And special relativity has been confirmed by 11 independent experiments, so it seemed like case closed. Nothing can go faster than the speed of light. But one of the things we've learned in studying the phenomenon of gravity is that it apparently exhibits behavior that is faster than the speed of light. And then we went back and tried to understand how that can be so in Einstein's theories, and there's a very simple explanation. Lorentz invented a version of special relativity and published a year before Einstein. It's called Lorentzian relativity, and it is a theory which does allow faster than light travel and passes the same 11 experimental tests. But since it allows things to go faster than light, it allows us to explain gravity and the 6 new modern experiments that show gravity going faster than light, which Einstein's theory does not accommodate. So the answer is that Lorentz's variant over Einstein's special relativity, this doesn't affect general relativity. Lorentz wins out over Einstein when it comes to special relativity. The Lorentz version is right, and things can go faster than the speed of light, and there is no universal speed limit. And gravity is an example of something that, according to the best experiment we have, travels at least 20 billion times faster than the speed of light.
Wow. Okay. That was a pretty good quick synopsis. One more time, what are the books that you have, and how can the average person buy them? Can they buy them off your website, or do they go to Amazon? How do you get one?
Amazon carries Dark Matter, Missing Planets, and New Comets. You can also get an author-signed copy by buying at our website, metaresearch.org. Just click on the store. There's no advertising otherwise on our site, so it's safe to visit. I publish, I'm the editor for a quarterly bulletin here at Meta Research, where you can find all kinds of the newest things going on in the field of astronomy and the newest things that relate to all these theories we've been talking about today. And the website itself contains a lot of material, hundreds and hundreds of pages of varying degrees of broad interest or technical details, which people can immerse themselves in and have done so, and can read on for days to their heart's content to try and understand better all the mysteries of the world around us.
Excellent. And, okay, we got about 4 minutes left. Is there any kind of final thought or word that you would like to add?
Let's see. In deference to your earlier caller who was fascinated by that one idea about the concept of gravity, I'll just do a real quickie on that. Newton's idea, Newton had no explanation for why gravity was the way it is. It seemed like a force that came out of the earth and held us down. And Einstein added a kind of quaint explanation. He said it's the curvature of space-time, and it's just geometry. But there are some objections to that explanation. In this new kind of way of thinking, there's a simpler way to think of gravity. Think of the universe as filled with a flux of very, very, very tiny particles, much smaller than our smallest subatomic particles. And these are very fast-moving entities, and any two bodies in space would be constantly bombarded by these entities, but they would shadow one another from some of them, so they'd wind up getting pushed toward one another because of shadowing each other from some impacts on their on the surface facing the other. So that would look to the bodies as if they were attracting one another, when in reality they're being pushed toward one another from the outside. When you're standing here on Earth, the reason the apple falls from the tree is not because of something coming out of the earth pulling the apple down, but rather because this big flux of gravitons, as we call them, hits. The more of them hit the apple from above than from below, because the earth blocks some gravitons from getting through to the apple on the underside. The result is a big push down, and the apple falls from the tree as soon as it can get away.
Wow, that's really awesome. But we're gonna have to let you go, Tom. We appreciate you being on the show. It's just really, really fascinating stuff. I mean, 2 hours is literally not enough time to talk to you about these things. We appreciate you taking your time out and being on the show with us. And I hope you can come back on.
We'll do it again sometime.
Okay, thanks a lot.
All right, take care.
Okay, you too. Bye. That was Tom Van Flandern. The universe is a drop of water on someone's forehead.
That's just...
Whoa.
That was almost a point there.
Keanu Reeves.
Where I almost wanted to do that. Whoa.
Oh,
Energy
man.
can't be created or destroyed.
And as Radiohead says, gravity always wins.
Gravity always wins. That's right.
This is Jay Scott, your only JDDJ on the Omnitown Radio 1 Network.
This is Trent Lackey. We're coming to you from Kernersville, North Carolina, where, especially tonight and always, small town, talk about very big things. All right, D, you gotta...
Yeah, we don't have Chuck to do his little...
I know.
Yeah.
Well, D's gonna have to just make up something in about the next 15 seconds. See you guys.
See you guys next week. And as Chuck always says, we out!